Alright guys, so we'll just carry on with this example here. Hope you've had a crack at it in between videos. So prove that the straight line y equals 1 minus x touches the parabola y equals x squared minus 3x plus 2 only once. Once again, you'd use substitution. So 1 minus, where does 1 minus x equal to? X squared minus 3x plus 2. Once again, you move every value, so you make one side equal to 0. So the other side has all the x values on it, so you'd add x on, so x squared remains unchanged, plus x minus 1, so plus x, negative 3x plus x is negative 2x, minus 1 plus 2 is plus 1. Okay, and that, to solve that, is 0 is equal to x minus 1 multiplied by x minus 1. What adds to give negative 2 multiplies to give 1? Negative 1. So 0 is equal to x minus 1 squared. Therefore, x is equal to 1. Okay? When x equals 1, y is equal to, substituting back in, 1 minus 1, which is equal to 0. Therefore, meet at 1 point. Sorry. 1, 0. And once again, you could graph that. Okay. So basically with these, and this needs to be copied down, guys, with these simultaneous equations, a quadratic and a line will meet either twice, in this first case, where they intersect twice, with two solutions, once, where it's a tangent, one solution, or 0 times, where, because of the gradient of the line, they never actually meet at all, as shown below. Alright, so second exercise that we're going to get through on Monday is looking at families of quadratics. So families of quadratics are similar to families of straight lines. However, in this case, we can have two unknowns. And this is an example down here of a family of quadratics of the form y equals ax squared plus bx. So in this case, the a term can change, which would change the gradient of the parabola. And the b term can change, which can change the turning point of the parabola. A could also be negative, which means you'd get these negative lines down here. Or it could be positive, which means you get these positive lines. And as A and B changes, you can get different things. So what I'd like you to do in your books, guys, is just go through seeing whether you can actually plot these ones yourself by finding the x-intercepts and the y-intercepts, to just work on that skill there. Okay, so basically questions for this will rely on your ability to substitute and manipulate simultaneous equations so that you're able to find one unknown. So I'll just go through one example here, and then we'll do some more in class on Monday. So a family of parabolas have a rule of the form y equals ax squared plus c. Find the parabola in this family that passes through the points 17 and 210 to find the values of a and c. So this is going to create a simultaneous equation where you sub in the points. Okay? So you've got y is equal to 1 squared, a times by 1 squared plus c. Actually, redo that. Probably going to have to go into another very short video to finish off this question, guys. So sub in 17 into the equation. So you'd have 7 is equal to a outside of 1 squared plus c. And you'd also sub in, you'd simplify that first. So 7 is equal to just a plus c. And you'd also have sub in 210. So 10 is equal to 2 squared a plus c, or 10 is equal to 4a plus c. We'll finish this off in the next video.